Hello YouTuniverse, Alex here. Hey, I've got a question of you. How many of you guys watched that video yesterday that explains how all the planets formed on a plane, on a flat plane from the sun? In that video, I explain how a cloud of dust formed into a disk, and that's how the planets formed along the plane. Now, that may leave you wondering, how are the planets spheres and not flat disks? How is that? Of course, if you're a flat earther, then you're just going to accept that this is further proof of flat Earth. Someday I'll probably do a video on Facebook explaining why people believe in conspiracies, but more on that later. Let's start with gravity. So Sir Isaac Newton actually created a mathematical equation to explain the force of gravity. And that formula is F equals G times M sub 1 times M sub 2 divided by R to the power of 2. Now what that is F is force equals gravity being G, M sub 1 being the mass of one object, times M sub 2 being mass of the second object, divided by the distance between two objects, as in R to the power of 2. Let's make something very clear. Mass is not weight, okay? Mass is the amount of stuff that it takes to create an object. Weight is the amount of gravity that pulls on that object. So let's put that into perspective, okay? The sun weighs 2 octillion kilograms, or 4.4 octillion pounds. Of course, this is a rough estimate, but more than likely pretty accurate. Now this is 99.9% of all the weight of the solar system. But why does this even matter? Some of you may say, I don't even like math. Well, let's say math is the language of science. The more something weighs, the more mass it has, therefore giving it the more gravitational pull on an object of less mass, therefore bringing those two pieces of mass closer together. So if one object plus one object equals two objects, and those two objects plus one object equals three objects, and all those objects have mass, then their added mass has more of a gravitational effect on the other two objects and one objects in their vicinity. Then you could clearly see how this would have a compounding effect on everything around it. So now the nice thing about space is it is actually the absence of gravity. It's only the objects within space that have gravity. So as these objects keep getting bigger and bigger, and there becomes less objects just free floating around in space, those larger objects start acting upon other larger objects to slow them down. So as far as space is concerned, less objects equals less friction, which equals less heat. However, the objects that have collected all of the smaller objects into them equals more objects in that area, creates more friction, which creates more heat. So all of this friction that's being built in those areas are actually creating heat that's melting the solid particles in them and creating more of a soup, if you will. If you watched my How Does Ice Float video, then you know that the less dense items float to the surface and the more dense items sink down to the bottom. Now, that has an amazing effect on these newly created planets. Now, as the dense objects continue to move closer to the gravitational center, this builds up pressure, solidifying that gravitational center. And everything outside is still constantly in a level of motion because of the friction that's being built around it. Don't worry guys, we're almost done here. So as the center starts building up pressure, it actually forms solid. Now that keeps spinning and continues to provide friction for the rest of the liquid that's on the outside of the planet and on the inside of this planet. Now that's the nice thing about gravity, because as this sphere, this solid sphere has formed, all these other pieces that are constantly in motion are starting to pile up, and still in liquid form are piling up around that solid piece. And as it gets larger and larger, it continues to stay in that spherical shape. So as the outside crust, if you will, is full of the lightest materials, there's no longer as much movement going on, which helps to solidify the outer crust of the planet. Now, keeping this spherical shape through slow but steady centrifugal forces, we, using gravity and what we understand about an object in motion, can easily explain why this isn't a perfect sphere. It's still a sphere, but it bows out a little at the equator of all planets. So the gravitational center of the planet acts on all edges, the outside crust of the planet, to keep this spherical shape. As always guys, don't forget to click subscribe, and you guys have a fantastic day.